Okay, here we are. Welcome to Psychology 1. We're in week 8. We're going to start working on memory. This week we're going to do part 1 of memory. What is memory? And how do we do that? So we're going to look at sensory-based learning, short-term memory, also known as working memory, and then into long-term memory. And we'll look at some theories about memory. And we'll just do that as an introduction to what memory is. And then part 2, we'll look at the other part of memory. So this is something that will help you understand about why is it sometimes I don't remember things, and we'll pick up a lot about that in the second part. But you'll start to see how is memory made up, and what is the function of each part of memory, and why it might help you understand a little bit about why you may remember some things and why you may not remember other things. And then part 2, we'll explore memory a little more specifically at how it might apply to you. So please pay attention to this, pull out your textbook, make sure you're making notes, because this might be very helpful for you, not only in this semester, in this class, but also in other classes and in other semesters, and certainly in your future. Good luck.
Okay, let's first begin with the process of remembering. There's a stream or a method by which we take note of things for remembering. It begins with encoding, and encoding is this sort of putting it into a form that our memory can be stored and that we'll make sense of. And now encoding is influenced by a variety of things that include learning styles. So it could be based on visual information, auditory information, kinesthetic information, or things that we touch. We can gather information through these different senses, through things that we smell, things that we say, and even to some degree the energy that we express and feel. These can all be elements that contribute to the encoding of information to be stored. Now, of course, we're not limited to that, but once we do have what we would call our encoding, we then have to create storage, basically maintain the information for memory. These are done physiologically, that is to say that in our brain there are physiological changes that occur in the brain to support memory. And then lastly, we have retrieval, and this is to make access or give us access to those stored information and bring to mind the things that we need to know. Now, memory failure can happen at any one of these stages. And so we're not limited to memory failure in the way we encode or in retrieval. Memory failure can happen all 3 stages. Now, there's been many different theories that sort of look at, memory and where does it come from and how does it happen. We're going to look at one that's called the Atkinson-Schriffen model. And this is a model that has come under some controversy lately because of what new information we have. But this model is basically looking at the human brain is somewhat like a computer, that it's an information processing system. And it uses the computer models and computer terminology to describe the human cognitive functioning. And so the Atkinson-Schriffen model is a memory is that information processing model that proposes that there's 3 storage systems. There's a sensory, there's a short term, and a long term. Now, this you'll find in your text, I think, and the step 1, and you can see the relationship between what we do with our brain and what is done with the computer as to why this model seems to make sense. The encoding is this process of putting information into a form that can be stored. The stored is the retention of information. It operates a bit like your RAM does on your computer. Consolidation, this would be the physiological change that actually happens in the brain that facilitates the storage of pieces of information. And then retrieval would be the long-term memory retrieval, and this is where you call up this information. So in terms of this model, it seemed to be for a long time how we looked at memory, but a lot of what we've been doing in research now seems to look at the brain is a lot more plastic than it is in a sort of structured, formatted, hard-based like a computer. However, the process of putting things to a hard drive and working through random access memory and inputting things through a keyboard, mouse, touchpad, or some other means does seem to have some relationship to the brain and how we do this. Now, as mentioned, there's more than one part of memory, and we're going to start with the first, and this is what's called sensory memory. And this is where sensory memory holds information that's coming in from these different senses, visual, auditory, kinesthetic, sniffing and smelling, and it holds it just for several seconds. And this is just long enough for our nervous system to sort of pay attention to something that's important or to disregard that which is unimportant. So the nervous system begins to process the information and send some of it to short-term memory. Now, this is a really, really small period of time that the sensory memory gives us to make sense of the world around us. Now, for visual sensory information and memory, it's a fraction of a second. And for auditory sensory, it's about 2 seconds. So if we don't do something with the information really quickly, then it can be something we disregard or it's gone from our memory potential. So sensory memory allows us to survey for important information and draw our attention to things. And so if you're in a classroom and you notice a sound that it occurs and you turn your head to pay attention to that sound, that's your sensory memory picking up on something that you acted on and therefore made sense of. But a lot of time there's sensory information we don't pay attention to. Perhaps in that same classroom you don't notice the sound of the fan of the projector up in the ceiling that's projecting the image on the screen. And so your sensory part of you doesn't pick that up and it doesn't make sense of that information. And that's the sensory memory. It's only accessible and giving us access to information for a very short period of time. Now, what does get in, and we do pay attention to, moves to short-term memory. And this is a temporary store that picks up information from the sensory memory for further processing. And this is not a very long spot for information to be held either. So when we look at this, short-term memory, it codes information according to sound. So the letter T is remembered as the sound T, T-E-E. And this short-term memory is also known as working memory. Now, the information held in working memory or in the short-term memory lasts for just about 30 seconds, unless it is actively processed. Okay, so in order to actively process, we need to do something with the information. Any additional information that goes into short-term memory essentially is displaced. And displacement occurs when the information previously stored in short-term memory is lost. So I give you some information and you don't start processing it and I add additional information. The first information gets displaced out of short-term memory, the second information starts to be paid attention to. And unless I connect it to something, that information could later be displaced by new information. So an event occurs when the short-term memory is filled to capacity. Each new incoming item pushes out existing information, which is then forgotten. And so there are different strategies that we use. One of those strategies, this image here of the water, is what would be similar to displacement. That when you add information in, some stuff gets released and spills over. You can't hold an inordinate amount of information in your short-term memory. It's limited, and limited by 30 seconds of time. So one of the things we do is what's called chunking. If I gave you a collection of letters, one way to remember this would be to look at the items in smaller increments, and that would be called chunking. So X, IBM, SAT, ATT, PhD, and X is easier to remember that sequence in the blue by breaking it into smaller chunks. And that's called chunking. It's grouping or organizing bits of information into larger units, reducing the information to the number of pieces in the short-term memory can manage. So for example, we group, OHIP, OHIP, as being the Ontario Health Insurance Plan. The driver's license numbers, if you know your license, then you probably have chunked it into increments, into chunks of 3. Phone numbers are often done in chunks so we can remember those numbers. And so that's part of how we do our memory, and how we can use short-term memory is through chunking and through rehearsals. And so we do it several times. And so, for example, here's 4 chunks: FBI, TWA, CIA, IBM. These are easier chunks because they become recognizable. Phone numbers are often done in this manner. It enables us to better remember them than to have a full sequence of 9, 10, or 11 numbers, which typically in short-term memory we don't remember. Now, working memory can have a more functional purpose if we make use of some things. So let's look at what we could do with working memory here. Well, one is, in terms of working memory, is we use it to understand information. We use it for solving problems, we use it for remembering information, and we use it for communicating with others. Now, these are the subsystems, if you will. Understanding information, remembering information, solving problems, communicating with others. These are subsystems of your working memory. Working memory includes speech-based short-term memory, as well as other kinds of temporary stores that hold other kinds of information like visual, kinesthetic, and such. So memory strategies such as organizing information allows memory systems to take better and more efficient use of the short-term memory's limited capacity. So one example would be maintenance repetition or maintenance rehearsal. And this involves repeating information without transforming it. So we're using it exactly as it is and repeating it and repeating it. Repeating information to keep it in short-term memory so it doesn't get displaced leads to storage in long-term memory, or you choose to discard it because after repeating it you recognize you don't need it or it's not of value, and so it gets disregarded or discarded. But maintenance rehearsal is one way of taking information from your working memory or your short-term memory and putting it into long-term memory. Another version of that is called elaborative rehearsal. And this is the process of using prior knowledge and adding meaning to new information or making it more memorable. So you connect the new information with other information that you already know. So you know something, if you're in healthcare, about injuries. You've had injuries before. Maybe you've had a cut and you've had a Band-Aid put it on, you've had some ointment put on it. And now you're in the nursing program and you're learning new information, and you're going to add it on to your existing information, or you're going to alter some of your existing information. And that's called elaborative rehearsal. It's just connecting new with prior learning. Now, this is all what we do in the working or short-term memory, and the idea is to take it to long-term memory. So if we look at long-term memory, this is an unlimited capacity and relatively permanent storage capacity, and information gets put into long-term memory by rehearsal. It doesn't get in there automatically. There's not a shorter route to get it there. It's there through rehearsal. Now, when we look at long-term memory, it can be seen as both declarative memory and non-declarative memory. When we look at declarative memory in a long-term management system, that holds information that can be easily expressed in language. Therefore, it's declared in language. You state it, you say it out loud using language. It's declared. That's what makes it declarative memory. And there's two types. There's episodic and there's semantic. Now, declarative memory can also be described as what's called explicit memory. And this is where we store facts, information, and personal life events. That's why we can express it through language. We talk about what's going on in the world around us and the things that we know. This is something we express and communicate to one another. These can be brought to mind verbally or as images. We don't need any prompts. We can just talk about them. Declarative. So episodic memory is a subsystem of declarative memory that includes information about your personal experiences. Your life's diary, if you will, is kind of like episodic declarative memory. It records events as they've been subjectively experienced, so it's your point of view of the world around you. Now, by contrast, the semantic memory is a subsystem of declarative memory that includes general information or objective facts. Information be kind of like your dictionary or encyclopedia. It's not necessarily based on your own subjective view of the world. This is more the sort of objective facts and information that we are aware of and about what you might learn in school, for example. And so you have these two forms, and these are things that often we would say are expressive. If I asked you a question about psychology, you might be using your semantic declarative memory to give me a verbal response. Now, conversely to declarative memory, we have non-declarative memory, and this stores motor skills, habits, and simply classically conditioned responses, these associations that you've made to learn things. It holds information that's not easily translated into words. For example, you don't easily describe to me how it is that you can ride your bike, but it's memory that even if you haven't ridden your bike in 10 years, you can get on a bike and ride it. That's non-declarative memory. It also includes behavioral responses acquired through operant and classical conditioning. So the kinds of things that fit under non-declarative is bike riding, typing, cooking, things that you don't have to describe verbally to do it. You can just physically remember how to do it. And so your long-term memory is a little more complex than maybe you first thought, but how information gets in there is not just by saying it once and putting it into long-term memory. That requires more effort and more work to do that. So an overview at looking at memory is this image here. We have long-term memory that's divided into declarative and non-declarative, often described as explicit memory versus implicit memory. And then you have episodic and semantic memory following underneath declarative, and you have the motor skills and the classically conditioned responses under non-declarative. Then lastly, looking at the system of memory and how it works, we can look at this image here and see that at sensory memory, sensory information is brought to sensory memory, where we can have some information loss here because we just didn't pay attention to it. That what is paid attention to is transferred into short-term memory, where if we rehearse it, it can be transferred into long-term memory and therefore retrieved to access in short-term memory to be used. Now, if it's transferred from sensory memory into short-term memory, and we don't rehearse it or rehearse it inappropriately, then we could get into forgetting. And of course, if we transfer it and do so unreliably through non-rehearsal, then that's not surprising that we may not remember in long-term memory. It may be lost due to not having had rehearsed it. It's where sometimes if you do mass studying, you cram, the information is rehearsed, but it's not really understood. It's kind of like putting it in a long-term memory, but not labeling the folder that it's in. So that when you go to write the test, sometimes you can almost imagine seeing the page the information's on, but you can't find that page. It's not reliably in long-term memory because it wasn't rehearsed over the longer period of time to make it more firm and steady in long-term memory. Okay, this is the end of this particular video looking at the introduction part of memory. I hope you found it helpful and hope you'll take something from it that will make sense for you. And we'll move on to the next segment of it shortly here in the next week. All right, well, good luck to you and keep on the good work. Bye now.